Hello, good morning, everyone. My name is Gorky Vemlapalli. I'm a senior architect with Xerox Government Healthcare Services. With me here is Thomas Hurek from
Hi.
IBM.
Good morning and welcome to our session. My name is Thomas Hurek. I'm for now 12 years with the IBM development group for WebSphere portal and one of the main components used in the enterprise.
Yeah, so Xerox and IBM, we worked together on this, the massive scalability effort that we had to do as part of our government health enterprise portal. So just to give you a background, my background is in architecture and and technology, and I was put in charge of this massive application with 7+ million lines of code, which can run a state's entire Medicaid system, basically. So this is like runs the entire state's Medicaid, irrespective of it is California, New York, or smaller state. So that's what the platform that we're talking about. We call it like Health Enterprise Portal, but it's like an entire platform, like with all the pieces together. It's a pretty complex platform. So the challenge we had was it's a massive code base, and there is like a core application layer with like multiple middle tiers and stuff. And then you have like a lot of COTS products that integrate into the product, and then you have EDIs, like stuff coming from EDIs, and you have things coming through IVR, and there are like multiple points of entries, and like there are like a lot of integrations. So it's a pretty complex application. I'll walk you through into. So the challenge that we had was to scale this application from like a state with 100,000 members to a state with 10 million members, which is you're talking about starting with Alaska, we went live, and then we had to scale it to like California, which is the largest state for Medicaid in the country. So that's the challenge that we solved, and AppDynamics actually really helped us a great deal in this whole effort. Without AppDynamics, we could not have done this. I mean, I can simply say that. Yeah. So I'll start with about Xerox. I mean, probably a lot of you guys would know about Xerox as a document company, printing company, and a photocopier company. But yeah, Xerox is into a lot of other things. Xerox runs Xerox like founded in 1906, 140,000 employees, 2014 revenue of like 19.5 billion, and we are active in 190+ countries. So Xerox is into technology, and as well as Xerox is into a lot of other services. In fact, Xerox runs like most of the toll collection systems in the country right now, the majority. A lot of other programs, food stamps and what are eligibility programs in the states that you hear about. All kinds of treasury related services. Xerox is into a lot of different things, transportation or whatnot. So right now the Xerox is more of a services company than a technology company. If you look at it that way. So I mean, we have the core technology, but we are diversified into a lot of different industries and different areas. So Xerox Healthcare Solutions. Quick facts, as you can see here. So we are in 37 states and District of Columbia. We support the government healthcare services, and we have 563 million health program claims processed annually. That's quite a big chunk of claims that are processed across government healthcare. We have around 6,000 employees focused on this area, and we have $13 billion in drug expansion programs, and all other nice numbers that you can see there. Xerox Health Enterprise Framework, so the one that we are going to talk about today, and how about the scalability and how we scale the system. That consists of multiple different facets. As you can see here, we have clinical support solutions, and we have eligibility and exchange components, which checks the member eligibility information. We have pharmacy management, pharmacy and pharmacy benefits management. We have also automated authorizations. That's like for the patient's pre-auth and service authorizations. And the core components in the health enterprise, again, they have a bunch of core components that deal with provider enrollment, member enrollment, third-party liability, benefits management, and we have our own claims adjudication engine. We don't depend on third-party claims adjudication engines. We have our own internal engine. It's a pretty complex claims adjudication engine. And we also have EHR and HIE component, electronic health records, and health information exchange components as well too. as part of the Health Enterprise Framework. So getting into the Medicaid Management Information Systems, we call it MMIS. This is a system that runs a state Medicaid program. These systems are the preferred Medicaid management systems across the states. So we had, so to give you a background, so Xerox already had a legacy system, which is already run in like 20 plus states already. And the Health Enterprise is a modern platform that we built it's a next generation system using the latest technologies and latest middleware components and whatnot for the next generation system. So we have a mix of both the things. So, we monitor end-to-end healthcare program administration in the states. And we also automate a lot of the regulatory affairs because the regulation changes so fast in the healthcare space. So we just make everything configurable and all that as part of the system. And it interfaces with the existing systems that the states have or whatever the systems that we have to interface with. And the input is, as I told earlier, it's from multiple sources, it's a web, phone, batch jobs, or it can be programmatic, or it comes through EDI. So we have integrations into multiple things. Features, yeah, service-oriented, reusable, fully aligned with MITA, flexible, and more than 40 years in the space. It's all the regular buzzwords you hear in the architecture. So yeah, we have all the good stuff. So use cases that we have is, providers, they enter the claims and other information into the system, and for them to for the state to process the claims. And end users can check their coverage and their eligibility and all that stuff, and then the claim status through the same portal. And the state employees who administer, they can either approve, deny, or they can do the other administrative tasks related to the claims too. And we have third-party integrations into all the other components that they need to integrate with, depending on the state requirements or whatnot, whatever their EDMS system they may have, or they have some other eligibility system that they want to use. So this is all plug and play. So yeah, we can just take our component out, and we can plug it in with the other system that state has and all that. So because that's how it happens. States, they say, we want everything together, but again, when you go to implement in the state, they say, no, we want to keep our eligibility system. Oh, no, we want to keep our provider management system. So this is built in such a way that it's all modular and pretty easily configurable. And we also have batch processing for all the other things that had to be taken care with some intense processing through batch. I'll cover the architecture quickly. I don't want to take too much time on the architecture and all that. Just to give an understanding of the scale of the system, I'll cover the architecture, and then we'll move to the scalability. So this is a modular system, as you can see here. So we have different pretty well-defined layers and different components at different layers as well. All the way starting from the presentation and access layer, where we heavily use IBM portal that actually runs our presentation layer. We also have some HTML5, for a few of the components that we introduced for the external facing, member facing portals and stuff, but it's mostly the portal. And we also have the presentation, right? As in the part of the presentation, it's not just a web application, right? As you can see, we have integrations into EDI, and all web services, APIs, and all other stuff, as you can see, including the IVRs too. And the middle thing is the common runtime infrastructure, which consists of all the different components that you're seeing here, the whole client management and all the way to the care management. So we have all these the components that's put together, either on each of the components, where the functionality is exposed either as atomic services or a composite services based on the needs of those particular modules. And everything runs on the enterprise service bus, ESB, behind the scenes. And you have all the data access layers and all that, and all these cross-cutting concerns are all just listed below. So interoperability and MITA standards and whatnot.
And of course, the solution had to be highly secure as well as auditable and loggable to go back in time to see events happening as well, to track who approved what, and that's a big requirement for the states.
Yeah, that's a good point. Yeah, security is very critical for us. So yeah, we have a very high level of security throughout the entire system.
I'm sure you've heard of HIPAA before. It makes the implementation more interesting.
Yeah, much harder, for lack of a better word. So yeah, so this is the presentation layer. I will not go into too many details. I mean, most of you you will know what the systems are, right? So this is the presentation layer, as you can see. so more in detail, what are all the different inputs that we get. That's what this explains here in this slide. And that is the business process layer. It's again, so we have like a lot of process orchestration in the business process layer using IBM Process Server, especially for like a lot of the complex flows that we have for claims adjudication and all that. It has to be highly configurable because just because given the nature of the regulation changes, so it has to be configurable. Otherwise, you can't really maintain the system. So that's the reason, like, so everything is orchestrated and everything is very highly configurable. But that also presents challenge with scaling the system. Yeah, you want it flexible, configurable, modular, and you want it scalable too. Like you also want like sub-second response times, which we had to meet some of the SLAs and stuff. So that's where it gets challenging. That was the challenge that we had. So yeah, we built this wonderful system. So how do you make it work, for like larger states in the country? So this is the services layer. This is like, as I told earlier too. So we have composite services, which are comprised of combined atomic services, coarse grain versus fine grain. And we have a business services layer, and we have infrastructure services layer for all the infrastructure-related services and security or whatnot, right? They're all like in the infrastructure services, so we cover that. I just wanted to show one system interaction, to give you like a view of how things flow through the system. So as you can see on the left, so you have like a lot of users, different types of users. Like so you can see the provider there. You have a OCR system. It can be like the facility is like a hospital or like a big hospital group. It can be from Kaiser Permanente in California or from Sutter Health or whatnot. So that's where the facilities come in. We integrate into the hospitals. They actually directly integrate into our EDI, and we have separate dedicated lines for those type of integrations as well. And then of course members, call centers, and TPs, third parties. So these are all certain integrations that we have. And the second layer, that's when the claims come. So this is the flow that you're looking at is the claims processing. Yeah, the claims mostly come through the EDI, or sometimes we get paper claims through OCR, and we run it through OCR and just get as much of data that we can, and then there's a manual part involved, but we're moving completely towards electronic. It's most of it are electronic, almost 96%, 97%, depending on the state. And also, we also get requests for eligibility and all that you see below there, but we'll not go into that now. So on the claims, and then they come to through our inbound B2B, and then we pick the claims from there, and there's certain checks that are done for HIPAA compliance and all this all this scrubbing that you had to do on the claims and all that, and then they flow through the adjudication engine that we have in Health Enterprise, where the actual processing, the claim adjudication happens, all the claim edits and all the rules are fired, and all the checks and everything bounce, and everything is done in the claims adjudication engine that is part of the Health Enterprise, the core part. And then they move to the outbound queues and stuff, and then that's where they get picked up later on. So and the output is again as you see, right? So and again they're routed back to whichever the audience is, where they came from, and whoever is intended to receive the output of this claim. So this is this is in a nutshell. So how the system works, it's yeah, it's not like a little pretty web application. I have done a lot of those before. And also we have it's not a cohesive one application, right? So you have a lot of dependencies of a lot of different external components or whatnot. That's where the challenge comes in.
And of course, those are maintained by different teams, different organizations, and it's not always easy to interface. And as we all know, whenever it comes down to performance optimization and challenges, the blame game comes up. It's no, it's not my component, it's your component. No, it's not my component, it's somebody else's component. And you don't even know who is responsible, but it's definitely not my issue. So I'm sure you guys have all been through this at some point in time, and this is also where AppDynamics has helped us a lot to be able, in a common tool that everybody can use with delegated security model, to see what is actually going on a really low level. So on an actual component method level, to be able to see what is being slow. And it's hard to debate that a certain method executes in a certain amount of time, or how much CPU it uses. But if it uses a lot of CPU, you might just start looking at it and find an indefinite loop in there or a loop in there. And based on that, if you can show that evidence, usually everybody is willing to change it. it's very hard to argue with a CPU execution than with like, oh, it looks like it might be your component. So that's where AppDynamics has helped us a lot. Yeah. So coming to the performance optimization. So the goals that we had, and those goals were actually defined by the states. And we had a real challenge here with both California and New York being very strict because they don't want their users actually to have to wait to a system. And we had a big goal on throughput. The throughput goal was an amount of users that will actually perform different transactions as well as for the batch processing. So batch processing, what we heard earlier, is for instance claims that get scanned or claims that get submitted that need to be processed in a batch fashion to determine if they're eligible or not. So that's one sample. And there's a lot of other different data cases that get imported over time. And of course, those should happen in a certain amount of time. If they run over from the night into the day, when the state employees come in the morning and they want to approve the cases, and the cases have not been processed, that's a big issue for the state, of course. So that was another important case. And then, of course, the response time. And nowadays, we just talked about it earlier, in the past, people were like happy with the average. So if the average is below like 5 seconds, everybody was happy. Now we're talking about like the 99th percentile has to be below 2 seconds or maybe below 1 second for certain use cases. So it comes really down to optimizing the last piece out of the system. And that's where AppDynamics has really helped us to trace that down, to solve the bottlenecks, to involve all the different components and teams that were interacted with in the system. And as Gorky mentioned, depending on the state, it could be in one state, one provider does eligibility, and in a different state, it can be yet another one. And in each state, then we have to interact with that component and tell them, look, we can prove from the system, here's a screenshot from AppDynamics, or you have access to AppDynamics, where we see that call takes 10 seconds. If we have a 1 second response time, 10 seconds just won't cut it. So the implementation that we took for the Scalability lab, so we defined a lab system inside the Xerox Enterprise that modeled what the actual state would look like. And in there, we followed an agile process to optimize each iteration and to see how the performance improved. The tool that we used for performance execution was a rational performance tester here from IBM, but there's quite a bunch of different tools in the market, like Load Runner or Storm Runner, or even implementations of other vendors. Then after performance testing, recording and playback, we would analyze the recording issues, identify what are the most important ones to fix, and which can be fixed within the current iteration, or which have to be deferred to the next iterations. And then we worked with the different teams that were involved. So there's a lot of business partners involved that were responsible for different areas in the code. They made those changes. We applied the changes. We did some functional testing. We did tuning as well in terms of configuration. Yeah. And then we did the repeat. So we did testing again, finding new bottlenecks, see if the changes that we did actually worked. As you know, sometimes you think changing a certain parameter might make it much better, but in reality, you actually find out it's making it much worse. Well, that's something that you want to
Especially when you remove the bottleneck at the top layers. Like you think, oh, everything will flow through, and then it causes more problems down the lane and all that. So it's the whole pipe has to be clear. So eventually, yeah. And on the way we did it, so it was a 2-week sprints that we had with almost 70 people team. With multiple teams involved, IBM, as well as we had our partners, Cognizant and Infinite, who were involved. So it was a team, but we're very quick to move, So how was this all possible, right? I mean, thing is, so initially when we started this effort, before we found out about AppDynamics, here is how it used to work. We used to have dedicated team of 5 to 10 people. All they have to do is they go through the logs, why there is an issue happening, why is this transaction slow, and they have a whole triage process. They shift through all the logs and all the layers and try to come up with some assumption or some theory on why it is it's like that. So, and it was painfully slow, and it was not efficient. I mean, we had some tools in place, but none of the tools could give us an overall holistic picture of what's going on. So that was the biggest challenge. So that's when did some research and looked at the tools out there and then found out AppDynamics, to be the, best suited for our needs, and it was pretty easy to use and all that as well.
Yeah, and we had really good support from the AppDynamics team as well. Like whenever we had a question, they were able to help us and suggest changes to get used to the UI of AppDynamics and how to drill down the best way and to find the bottlenecks the easiest way. So in terms of major improvement items that we made in the overall system, and from what Gorky mentioned earlier, it's a fairly complicated system with a lot of different components involved. Like one of the main things we had to change was the heap size for the Java components, and some of the other components we had to increase the physical sizes as well. Then we did some extensive work on the connection pools, so that we don't bottleneck in any of those in terms of the flow down layer. But then we couldn't open up those connection pools fully either, because some of the backend systems that we had to integrate with, we don't have full control over. And those backend systems might only be able to handle a certain amount of cores in parallel. So again, there we had to configure the connection pool accordingly. Then the physical side of things, CPU and RAM assignments, that was a very interesting area that we spent quite a bit of time with. I'm sure nearly everybody nowadays is using some kind of virtualization. In our case, this was a VMware setup with vSphere. There's multiple other ways of doing this, but one of the big challenges that we ran into was vMotion problems that can be kind of tricky to troubleshoot. And while the team that was administrating it confirmed to us that it should only take 1 second to move a VMware image from one physical host to the other one, in reality we saw this taking like 30 seconds to 1 minute, and whenever the vMotion would take effect, suddenly performance would really drop.
So one migration of one VM would actually like mess up all the SLAs. Like that's what we found out. I mean, before we did not have insights, and our cloud team used to say, no, everything is fine, we're good. So stuff like this, I mean, you would not never know. It's always a blame game, between different teams and all that, especially in like a bigger organization. I mean, you guys probably like all know, right? I mean, I worked in smaller versus bigger and medium and all that, but it's a really challenge. Like, so it's all becomes a blame game. But this was like, gave us all the insights right there.
We also upped some of the versions. So we installed some of the fix packs that we knew had performance improvements, and we increased the version of the portal that we're using from 8.0 to 8.5 for gaining some of the new features. And in this case, it was the later version of web services. So we were able to get rid of the old web service stack and replace it with the latest web service stack. And that gave us like a 20–25% improvement. There was a lot of web services involved in this overall layer. And also as part of those web services, we took care of the logout functionality. So there's a lot of session functionality being used. And the sessions for an actual user can get pretty big because there's many interactions that the user is doing. And the user can still go back and forth between them and then in the end decide if he wants to really approve it or not. So in these complex workflows, the session can grow quite a bit. And one of the changes we did was during the logout of the user or the session timeout to take care of those data objects to clean up the memory. We also did some caching optimizations, not only for portal and web content management, but also wherever we were able to share data across the users. So that's, of course, a common thing to do is whenever there's data, it doesn't have to be retrieved all the time. For instance, we had a lot of labels in the UI that were common across users, and we were able to cache all of that data to prevent calls through the database layer. We also worked quite a bit on the indexing of the database. In our case, we're using Oracle here.
Exadata.
And that was Exadata, what was a very powerful database system that helped us a lot. But we still needed to figure out what were the slow queries. So as part of the AppDynamics usage, we could always filter out which are the slowest queries within our execution. And then based on those queries, you can actually get down to the actual SQL calls. So you can configure AppDynamics that you not only get like a cutoff version of the SQL. Typically, our SQLs would sometimes look like this. So other tools don't give you the ability to get a full statement, but we needed that to actually run the optimizer on the Oracle side. So that was another thing that really helped us to optimize database. In our case, we had like 10 terabytes of data, 6 terabytes of data?
10 plus.
10 plus terabytes of data. So it was pretty important for us to optimize database calls to not retrieve too much data, as well as also to have fast running SQLs. We also did some thread pool tuning, and again, AppDynamics helped us there. For the LDAP calls, for WebSphere, for EGB calls via the ORB, and WSRP, what is a standard for calling remote portlets. We also increased the number of JVMs where needed. This was the case for process server, as well as for the portal JVMs running on WebSphere. And that helped us a lot, and this was needed mostly for memory use case. So a single JVM can only hold a certain amount of memory, so we're able to fine-tune that and get better performance out of it. Then we also found quite a bit of custom code adjustments we could make. So we found quite a bit of redundant calls, so whenever we started drilling down into the code layers to see why a certain area is slow, with AppDynamics you get the ability to really drill down and see that within a certain root layer that consumes quite a bit of CPU or that is slow, across different components. Typically, a call would involve at least 5 different components. We could figure out that sometimes different sub-areas would call the same backend system to get the same data. And we were able to trim that down, and with that also improve performance a lot. I talked about the SQL statements. Then we also co-located. We had a separate business layer in the past. And the BPM layer was always making separate outbound calls to the business layer, and we found that this caused quite a bit of overhead just in the communication itself and the serialization and deserialization of XML. By moving them into one bigger JVM, and nowadays with the latest JDKs, you can easily run heap sizes of 10 or 12 gig without incurring a large garbage collection overhead. We were able to cut down on those. Another thing we did is making calls asynchronous. What I mentioned earlier was the auditing framework and the logging framework. All of these calls were in the past done in a synchronous way. And whenever there was quite a surge of requests, what would happen is that a lot of the calls all wait on the logging or auditing system to finally come back. So we made all of those calls asynchronous, and with that we can faster display the response to the end user and still log whatever was done as part of the interaction.
And also on the logging, one more thing to note is because of the whole sheer size of the system, so there are so many places like where the logs were configured differently, and like there's like one jar file where like the mode was set inside there to be debug or something. That one setting would actually slow down the entire system because like that logging would take like so much time and it will block everything else. So these kind of things like we would not have known without actually looking at the whole the trace. The trace where you see, oh, log.debug, why is it getting called? So instances like that too. So and then we made everything asynchronous after that. But
yeah, there are a few instances where deployments happened, and from the low environments, the development teams had put on debug trace and accidentally deployed it that way. Where whenever we would run even a short user test, we would see in AppDynamics that the logging shows up at top of the stack, consuming the most CPU. So it was usually an easy check to make to find out what was wrong and fix it. We also got quite a few fixes. We upgraded the Log4j version, and then a lot of people don't know, but you can actually use Log4j in an asynchronous way. You can configure Log4j to log asynchronously versus synchronously. That makes quite a difference in terms of otherwise you're deadlocking on a single log file that gets logged into. Then we're using Hibernate for calls to the database layer, and we had to again up the Hibernate version there. And we actually had to fix certain things there, work with the Hibernate team. On the JSF side, that was used heavily from a UI perspective. We, again, had a lot of interaction with the JSF team as well. And all of these things we could do because of AppDynamics, because we were able to troubleshoot and say, this JSF call takes a long time, why is that? We could open a PMR against different software vendors and send it to them. And without having to go like 100 times back and forth, send me this log, send me that log, send me this log, send me that log, you can just pinpoint, take a screenshot, show it to them, and they're like, oh okay, we're making this call multiple times and there's no need to make it. So that's also a good way to interact with different vendors to get a solution faster for bottlenecks. So AppDynamics, so how do we use it and why did we use it?
Yeah, so it was out of like frustration, So yeah, so basically like yes, we have the massive system that it has to be scaled, right? And we can't find our way around it. So one fine day, said like okay, let's see what's out there, and then So I was doing some research and then like comparing some tools out there, and came across a couple of in the top. I mean, we had some tools in our stack, but they're not giving us a whole picture of end-to-end and all that. So found out and then said, you know what, like let me try it myself. I run our team, but like I just like said like let me install it and see like what it helps. It was so easy, just like I could just download the agents and just put it on like one of the smaller lower environments we have, and it was like just like showing me like some of the things that like right out of the box. I was like, oh, this is pretty cool. And then that's how the whole thing started. And then we got it into like one of our lower environments to just test it, like whether how it works and all that. And it was so easy to just get it in there. Initially, yeah. So we had few challenges because we have like the whole stack is like so complex, and we have a lot of security requirements because of which URLs are all encrypted too in the portal too. So basically, you can't see anything after the context. Basically, everything else is encrypted. It's all security reasons. So we had challenges there. So we got through that. It's not it's not because of like AppDynamics limitation. It's actually the application that we have. It has the requirements like we have like that. So we came out of that. But the thing is, the pain that we have is we have like these people sitting there, 5 to 10 people. All their job is go and search through the logs and try to like stitch a transaction together to find out what is the issue. And by the time they find out, it takes a week, and then they come with like few things, and then like people fix it and then push it back, and then there is another problem that comes up again. So it was a never-ending cycle of like frustration, and like and you're looking at 7 million lines of code, and it covers the entire aspect of like managing a healthcare system for the entire state. You're looking at functionally, technically, and at the middleware components and the number of technologies used. It's complex, very complex. So that's where like we said like this tool is the one that can actually solve all our the problems. That's what we looked at, and actually it did. So we did not need those 5-10 people anymore, like just doing that. They could do something more productive where actually like they can actually look at the actual problems what are there and spend time on fixing those instead of trying to find out what the problem is, right? So this tool just like took it all that away. I'll give you one example, right? So one of the transactions that we have for claims adjudication. So initially, we were like, it's just like a simple one. It's not even adjudication. It's like one of the first initial claim input transactions. It was like painfully slow for some reason. And all the code looks fine, everything looks fine, and like we tried to like find the root cause before we brought in AppDynamics. No one could figure out what's going on. Everything looks fine, and all the analysis was done. What the problem was? It reads like a file as a part of the transaction. It reads a file from a network file system. And the NFS was slow. Because of that slowness, that will like block the entire transaction and it make everything slow. And we could find it from AppDynamics because there was a call to that NFS to get the file, and why is it slow? And then we found out that the network file system has an issue and stuff. So those are the kind of things, you will not get, just doing the regular way, without having this holistic view and, surgical precision that the tool provides, and which helps us like greatly. Yeah.
It was also very powerful that we could plug it in, for instance, to Oracle itself. That again gave us some interesting data points. So AppDynamics has a lot of different plug-in points. Like from our perspective, from the IBM side, we're able to use it with a lot of our tools, but also the other components that were used within the enterprise solution, we were able to plug it in and get the data out of it. And even without knowing the code, we were able to figure out that a certain method was slow and what it was calling that was potentially slow, and then you could go on from there, or hand it over to the development team and have a productive discussion with them, not playing the blame game again, but just saying, this method seems to be calling the following 3 methods multiple times. Is that really necessary, or is there any way to optimize that? Also, what was pretty cool is the automated baselining. So we were able to see differences. So AppDynamics would report to us if the previous run, we always had good performance, for instance, for a certain call for MQ series. And suddenly now this call was getting much slower than it was before. And then we were able to drill down and saw that somebody deployed a new change there that was actually detrimental versus an improvement. And then also we have to be very flexible with the solution overall, since we don't know like how the customer, this time the state, would deploy it. Like one state might decide they want to run ARX, the next state might decide they want to run in the cloud, the next state might decide they want to run on Linux or even a Linux. And the ability from AppDynamics to have agents for all of those different OSs, as well as for different software, is very powerful.
And also, one more thing to mention is just the fact that AppDynamics can be deployed on-premise. That makes quite a bit of difference, especially when you're in highly secure environments and you're dealing with the governments and all the security and all that stuff. It's very hard to actually get them to communicate. Get them to get their systems communicate with the cloud, something in the cloud. They get just really paranoid. I mean, it's like, yeah. So that's another thing too that helps a lot. That also helps us move quicker too. And of course, the cloud thing is great too. I tried that, but that also helps a lot.
Yep. So another set of reasons why we used that Xerox was to be able to follow a transaction. So whenever the transaction would arrive at the first entry point, in this case the HTTP server or the portal server, we were able to follow it through the whole flow. And that's an issue that some other tools don't have, is where we're able to see not only that call ABC is slow in the first layer, but that ABC calls layer C, layer D, layer E, layer F, and actually at F is where it's slow. It's not really necessarily the first layer that has slowness, and we can still follow a transaction through the whole flow. So that's a pretty cool feature. And then the other thing that helped us was to be able to use that history data. So typically the tests would run by the offshore team, what would happen in the middle of the night, and we would analyze during the day. And at a lot of enterprises, that's a common scenario where the actual performance testing might happen overnight when there's no load on the system, because you might be sharing systems with production or so. So we could go back in time and see what the important issue was. And even in production case, right? If there was some slowdown and maybe the help desk only reports that there was a slowness to you 2 days later because of all the process involved, and finally it arrives at your desk that a certain amount of users had issues during that time, you can go back in time and look at it. Or even better, AppDynamics will alert you. It can send you an SMS or it can send you an email to alert you a certain transaction that was performing fast so far, suddenly starting to degrade. It also helped us in the agile flow here, because we would on demand find out changes that need to be done that could go into the next flow. And within the next transaction that would be agile deployed, we could see it was an improvement or not. Of course, another important thing for all monitoring tools is to have a low overhead. Whenever you have a high overhead, like if you look at profiling tools, usually profiling tools can only be used for a single user, or they have quite a big impact. So the advantage here was to be able to use it without actually burning the CPU of the system, because we still had to make, of course, those 2-second or 1-second response times, even with the monitoring tool being in place. And of course, we also want to use that tool later on in production. Whenever California or New York State or whatever state in the country is going to use our solution, we want to ensure that we can still use the alerting as well as the dashboard to figure out if something is slow, why is it slow, and even take dynamic actions. Another thing that we really liked was to be able to build dashboards.
Yeah.
And the dashboards are kind of useful for the business team. The business team doesn't necessarily want to drill down and see that a certain method is slow. They want to see from an overall perspective, what are the main entry points, for instance, phone, mobile, web, and which of those main transactions are slow, or are there any issues, or everything is green. I mean, the only thing they usually want to see, everything is green. And if they're yellow, Gorky will get a call. So and we'll figure out what's going wrong. Another thing that we liked was to be able to detect transactions via URL patterns. As Gorky mentioned, AppDynamics was able to take a part of the URL. In this case, we implemented friendly URLs, and as part of each transaction, we defined which URLs belong to that particular transaction. And that way, we can now classify for the business team that a claim for an end user is fast or slow, that an approval for a business user is fast or slow. Another thing we liked is it's browser-based. You don't need to install any software on your system. Anybody that has a browser-based system can use it. In our case, we mostly used Chrome, and that worked very nicely with the AppDynamics. I haven't really tried other browsers, but I'm sure it will work as well. Yeah. And then the other part was delegated administration. So we want the ability for people to create their own dashboards, but we still don't want them to change some of the system settings inside AppDynamics. For instance, the drill down level in the transactions. We don't want to incur a huge overhead to get the last tiny bit out of it. We actually want to, if at all, maybe have that on one of the JVMs, but not all of them. So some of the adjustments we had to make while we were using AppDynamics, so we had at the beginning a few challenges in terms of the learning of the URL patterns, and we're able to modify that. Then the database extensions, we had to change the detail level for the SQLs to get the full SQL. We needed the full SQL to be able to put it into the optimizer, and unfortunately our SQLs were not like short SQLs, but they were spanning lots of different tables. Then the ability to monitor physical CPUs versus virtual was a bit of a challenge in the beginning until we figured that out, because nowadays everything is virtual. Well, if virtual 50% might mean 1 core, or it might mean 10 cores. So that was an important part to also catch. That's also related to the vMotion. So we needed to also work with the infrastructure teams to figure out the actual physical allocation and possibly plug in AppDynamics into the physical side of it as well. Then we used the PMI data. The PMI data is not directly visible. You have to drill a little bit down until you find the PMI data. But if you want to drill down, you get there and you can tune the connection pools as well that way. Next, we'll come to usage.
Yeah, this is a dashboard, like, as it shows in our system. This was in, real time when we captured, so one of the dashboards. So we'll walk through the usage. We want to do a small demo today here, but I don't think we'll have enough time. But I mean, of course, probably you would have all seen AppDynamics. I mean, we don't have to again show it to you, I think. Yeah, so the thing is, how we, so how we used to use the tool, how we, effectively could find the problems. We'll just walk through a little bit on that. So every time, so basically what we did was, so we set up the agents across our infrastructure, all the VMs as well as at all the JVMs. So they all started communicating all the with the controller and pushing all the data there. So we configured, we used to use the default dashboard there to just get the overall view of the system, what stage it is and all that whenever we are doing a test to with certain load and all that. And then we used to start here, and then we used to drill down from here, and also we have a lot of alerts that were set up based on different parameters. Either we get proactive alerts if something is slowing down before it slows down, or we would get alerted on certain things that are crashing or something wrong is happening or whatnot. So that way also we knew our system admins, and they know beforehand, this is what is happening, this is what is the cause and all that stuff. So that's how we used to isolate the bottlenecks and stuff. And then as Thomas mentioned earlier too, we always used to drill down into the transaction and to see at each level what's going on and what's the bottleneck and what exactly is the issue or whatnot. And the good part is we gave access to our teams, dev teams, and the folks who are doing the development too. So that way they also know, instead of waiting for someone else to tell them what is going on, they actually can go back at a certain time in the past too and see what happened at that point of time, and then proactively fix the things. That used to save a lot of time, all this back and forth round trip time. That way everyone had access to the tool, and then they're proactively finding issues and waiting for some admin or some infrastructure guys or someone to tell them this is a problem and all that. So that saved us a ton of time. So the whole system, I mean, if you look at it, right, I mean, 7.1 million lines of code. That's what we're talking about. And no one knows the entire system. And when I came in, I was brand new. Okay? So I came from a technology world, machine-to-machine communications, IoT. Come to this massive healthcare system, and the challenge is to scale it, right? So that's where the beauty is. It doesn't matter what system it is, what type of business, what type of application or whatnot, as long as it's modern enough, just modern enough, not the mainframes or whatnot, you can actually you can get up to speed right there. So that's the beauty of it. And you can resolve the problems too. In a matter of 7 months, we brought the system. I'll give you an example of a claim adjudication. Adjudication is processing the claim. We have real-time processing of the claims as well as batch. Our system does real-time. There are very few systems that can do real-time adjudication right there, from the browser and all that. Ours does that. That thing is so complicated, so complex. There are 2,000 rules that get fired and like 1,000 workflows it has to go through, each of the adjudication, right? So when we started the test, the average time for one claim adjudication was 300 seconds. Okay, that was before the system was crashing. Okay, once we stabilized the system with AppDynamics, 300 seconds was the average time. From there, within the 7 months, at the end of 7 months, it came down to 2.1 seconds from 300 seconds. I'm telling you, I mean, and that's a very complex transaction. That's the scale that we achieved on such a complex system, without knowing, all parts of the system. Everyone was new, and of course, IBM helped us, but they did not know the system as well. They knew their products, but that was there or whatnot. And we had some teams like who were Java developers and whatnot, and there are few people who had some knowledge of different pieces of the system, but no one can know everything in depth. But that's where like the beauty of the thing is. I mean, it doesn't matter what it is. You just throw it in anywhere. You can actually know what's going on, and eventually you will learn the system as well, and you resolve things pretty fast.
The auto discover feature is pretty awesome. I mean, if you look at the chart here, it's a fairly complicated flow that might involve a lot of course different backend layers, and sometimes you weren't even aware that a certain backend call needed to be made, and the people that originally implemented this might have left. And then, as you all know, there are some data graves where some Visio diagrams are, and those Visio diagrams people didn't update. So you look at what is real happening during the system execution itself, and then you look at the Visio and you go, well, it looks like this hasn't been updated in a while. So you can actually re-update or regenerate the graphics on like what a certain business transaction involves. And based on that, when you know what's involved, of course, you can also think about high availability, right? So if this transaction requires a call to Oracle, DB2, and SQL Server, then you can go to those according teams and ask them what's their plan for high availability, right? You might not even know that a certain code was added 2 years back that now requires a special backend call as well. And with AppDynamics, it allows you to find that out without having to read those 7 million lines of code.
Yeah, no one has time for that. So.
Yep, so in the tool itself, I mean, we would use a lot the dashboard view as well as the transaction snapshots.
This is server monitoring part, and this code level drill downs.
So in the code level here, again, that's pretty interesting where it's calling different web services, and you can see how much time they actually spend and what the actual SQL call is or what is being made as part of that. And you can see how much time is overall spent. And of course, it's only worthwhile looking at transactions that are actually slow. So a lot of times people would look at all kinds of things trying to figure out what is the thing to optimize, but it's the needle in the haystack if you don't have a good tool like AppDynamics to figure out what actually is slowing you down. Again, it has real-time monitoring as well, and it also allows you to take actual actions. So a lot of times now, and you could possibly start up more JVMs or scale a system out, or maybe alert somebody or put a JVM in maintenance mode, or take other actions that are needed in case there's certain business monitoring happening. Like just on Cyber Monday, the target site wasn't able to hold up, and one of the measurements they took was to not let you add things into the cart. They basically tracked you back, and you had to wait for like 10 minutes until you could put something into the cart. So again, these kind of actions you can code or adjust into the AppDynamics or different tools to take action to still be able to hold up the site while the transactions might get a little slower for the end users.
So I just wanted to add a little slide in the end, how we achieved, everything looks green. I don't know whether you can read it. It's like such a small text. Probably there you can, yeah. So
you can see the number of transactions we had to optimize. It was not just a few cases. There's a vast set of different transactions that we all had to optimize to be within the response time. And each of those transactions was likely calling a different kind of layer, or the flow that was going through was different. So one flow might call and involve a different database, might involve a different third-party provider that would check a certain credit eligibility or similar things.
Yeah, so so each of the transactions, the flows are different, and it's different stacks, different layers, different calls. I mean, it is. But I mean, as you can see, right? Look at the 100th percentile, right? On a system of this scale, and with the maximum volume possible, like, even the 100 percentile, like, I mean, the highest was like 7.7 seconds or whatnot for one of the transactions, like the 100 percentile. And if you see the 90th, 95th and all that, like, it's like sub-seconds or 1 or 2 seconds, like, even for the complex transactions. And averages were like pretty low. Average, if you take the average was like probably under 1 second for most of this. But we had to go by 90th and 95th percentile because of the contracts that we have with the states and all that. So that's how, like, we started tracking it. But averages were like mostly below a second. Like the few transactions which were like the claims, like, which was under around 2 seconds or whatnot. But it was actually pretty good. I mean, given the complex, the flow it has to go through and the processing that it has to happen in between.
And when we started, everything of this was red. So when
not
we
even
originally started, like, the JVMs would crash. Like, we wouldn't even
Yeah,
be
it was
able
not
to-
even red. Like JVMs, the first thing is JVMs would crash, right? So that's where it started from. So you set up the whole stack and everything. You hit it with the California volume, the largest volume possible. Within like first 10 minutes, like one after the other, like, red. So that's where we started from. And once we stabilized the JVMs, the 300 seconds and all that, all the good stuff that I was telling, that's where it was like, it's a 3-digit numbers, it started with. And we could get this, to this level within like 6-7 months, that's what, like, it helped us achieve. There was no other way we could have achieved this. I mean, yeah, it would have taken probably 3-4 years and probably, like, to get here or, yeah.
And it's also like very powerful going forward to be used inside the states because we will keep this monitoring in place, and that will also help us to do real-time monitoring when the system is actually live, to act whenever there's an issue, and also to be able to identify if there's an issue, where is the issue coming from? Is it from a backend system? Is it latest code that was deployed, or what could be the issue? And of course, we'll keep on doing this as well whenever code adjustments come, to keep on running, finding optimizations in an agile way, to do as part of agile deployments as well, performance testing.
Oops. Yeah, try.
So we're pretty much at the end of the session. If you guys have any questions, feel free to ask. Yes?
On-prem.
The question was it on cloud or on-prem? It was an on-prem setup here.
Yes.
Okay. Okay.
So what is the level of granularity that you set up on the on-premise controller?
This one. Yeah. So the granularity, we started with the default, whatever it came with, and then we tweaked based on what level of detail that we needed. And it's a case-by-case basis, right? Like for the SQL statements, right? We needed to know what's the whole SQL is. We had like long ones, so we just increased that, to capture the full SQL. For the transaction, the depth, whatever they call it, the tree depth or whatnot. So that one, like, we used to play with it. When we had to actually really get some real detail, we used to increase the depth and all that. But again, we used to reset it back to the normal level. The one thing that, though, is there is a limit on this. There's a threshold, like, number of transactions per second after which an agent does not, show the transaction. There's 50 or something that comes out of the box. That one we had to tweak because in the States we had to actually do the reporting on SLAs. So we had to have, like, metrics for all the transactions that are passing through. So that's one thing that we worked with AppDynamics team to increase it in there. Do you remember anything else?
Just the number of different transactions that we have in this case is vast. It's not just 50 different main transactions. In our system here, we had like over 200 different kind of cases that we all wanted to track and optimize. So we had to increase it to, I think, 300 from the 50 default.
Yeah, just 300.
The question is about the architecture. Can you explain a little bit what type of a controller what type of architecture and a controller you chose, and the data collection points? How did you scale the volume-wise and then maybe feature-wise as well?
Okay. So you're talking about the AppDynamics controller.
That is correct.
Okay. So the type of controller is like, I mean, it's you know, out of the box. Probably Satish will be able to answer more details on that. Yeah. All right. You've already got it.
We use the latest controller available in the market at the time, and you know, what is your next question? It is a single node architecture because you know, we are doing it in the lab. So when we move to the different states like New York, it is again, you know, high availability environment where we had 2 nodes, and one is active passive. Basically, like one will be active all the time, and the second one is the passive. So for the scalability, whatever Gorky explained, it is a single node environment which maintains all the transactions across all the, you know, different systems.
You mentioned needing to monitor both the virtual server health and the actual hardware. How did you do the actual hardware monitoring?
No, what we said was that was a challenge. We did not have that, you know. So we had to use SolarWinds and all other stuff that our cloud team had, Xerox cloud team had, right? So that's where, like, you know, yeah, that's what, like, Thomas was saying. That was a challenge at the time. I think now AppDynamics, they have a product for that too, I heard. It was announced yesterday or sometime. That would definitely help a lot, a great deal, if you can actually put that together with all other things in there too. Yeah, so we use SolarWinds. And for the VMs, yeah, AppDynamics will give certain details about the VM health, but actually for the more in-depth details and all that, we had to get access to the vCenter, you know, to take care of those, you know, the properly allocating the VMs and all other stuff.
Probably 2 ones that could probably be answered pretty quickly. Are you primarily just on WebSphere Portal, or do you have other versions? And then the vMotion, is that something you did with the machine agent?
So, yeah, so the front end is primarily the portal. For the web part of it, primarily the portal. So it's WebSphere Portal, basically. And for, yeah, we have some HTML5 and stuff, that the newer pages that we have in some HTML5 standalone pages, but mostly portal. And your other question is about the vMotion, right? So I didn't quite get the question on.
So the vMotion, it's like a vSphere concept, right? From VMware. So the challenge that we saw is whenever we saw in the Solar monitoring that a VM would move from one host to the other host, we would immediately see in the JVMs or the other code that was running within those a massive drop in the response time. And while we were promised it would only take a few seconds, like we saw it taking quite a bit of time. And to the other point earlier, unfortunately, we were not allowed to install any AppDynamics agents on the physical cloud systems itself. Otherwise, we could have also monitored those. But since, unfortunately, that part was not under our control, we had to use the Solar tool to look at those. But of course, if we would have been able, that would have been another option. Thanks so much.
Thank you.